Hello folks, we are once again back with this exercise 7.4 which we were doing yesterday, the previous sessions. They were simpler questions. Now this time, as it's put on the board, you can see the problem number 10, which reads that the integral is integral of dx over a root of x squared plus 2x plus 2. So you don't have it in the form like x squared plus a squared, or maybe x squared minus a squared, or like root of course, root of x squared minus a squared, root of 1 over 1 over root of a squared minus x squared, 1 over root of x squared plus a squared, 1 over root of x squared minus a squared. It's not in that form as such. So we have got to make a conversion and try to get it into that form. So that is going to be our work. So for this, we are going to use an idea of completing squares. So how we complete squares and we get the thing done into that form. That is what we are going to do. So first, let's consider what is there in the root, and then let's see how we can get it converted. For example, here we have x squared. Here we have x squared plus 2x plus 2, which we can always call it as x squared plus 2x plus 1 plus 1, 2. We are breaking it as 1 plus 1. Now, why we are doing it? Because we know our objective is to get it in the form maybe x squared plus a squared, any form, So that's why we are doing it. Now, the purpose of doing this is, this we all know is actually x plus 1 the whole squared. You can expand x plus 1 the whole squared, a plus b the whole squared is a squared plus 2ab plus b squared. It will come to this. So instead of writing this part, it's fine if we write x plus 1 the whole squared, and the 1 here could be written as 1 squared. We know 1 raised to anything is 1. Now what's the advantage? The advantage of writing it is your I is becoming dx over root of x plus 1 the whole squared plus 1 squared. We got it converted into that form. Yesterday I was telling you that a linear thing that comes will behave like x. So it's like x only, like it's x squared plus a squared, it's of that form. So it will behave very much like x. So we can apply this. So actually here you can very well apply the result dx over root of x squared plus a squared. That will come to log x plus, not like this x plus root of x squared plus a squared plus c. So let's apply it here. As I told you, x plus 1 will behave like x. So if you will apply that formula, it will be log x is x plus 1 for us. Now at this step, you can make a substitution u equal to x plus 1 and proceed. But I'm not doing it that way. Why? Because we have to get used to this way of doing it directly. Later on in the upcoming exercises, this is coming with the definite integral, where we have to substitute the limits also. So it will be very laborious if you learn it always by substitution. So if you learn it like that directly, even in the later exercises where the problems are voluminous, it will be easy for us to get it done. So that is why we learn it right away like that. But as beginners, if you feel that, no, I'm not able to get it, then you can make a substitution u equal to x plus 1 and then work accordingly. So here, as I said, because we perceive it as this particular thing, so it is log x plus 1 plus the given function. This you can write anything, this you can write anything. But actually, generally, it's better we write whatever is given to us. Plus c. It's the same. We've got it converted. It's always better that you write it. That's about it. So it's log modulus x plus 1 plus the root of the thing that is given to us. Quickly, so also let's move to the next problem, which is 11th one, which says that I is integral of, it's all going to be like that, 1 over nine x squared plus xx plus 5. So let's consider that and then learn it separately and then get the integral. So let's consider 9x squared plus 6x plus 5. Let's keep this 5 separately and do the little bit of manipulation that we will require here. See, it's clear to us that this 9x squared is simply 3x the whole squared. It's very clear to us that it is 3x the whole squared. 3 squared, 9x squared. So that way, 3x the whole squared. And the 6x, you can always write it as 2 times 3x So see, generally when we write terms a plus b the whole squared, what all things are involved? A squared 2ab plus b squared, which means your product term should have two. It should have an a coming from here, it should have a b also coming from here. But you look over here, you have 2, of course, that 2 is there, and this 3x is coming, but there is nothing from c which is coming. So when nothing is there, we can visualize as though 1 is there. So you think of this as 2 times 3x times 1. What does this mean? This also means that b is 1. See, that also means that b is 1. If b is 1, in order to complete the squares, you will have to get a b squared, which is 1 squared. So you have to get a 1 squared, we know is 1. Suddenly in an expression, you cannot add 1 squared. We have added 1 squared because we want to complete the squares. But you cannot just add 1 squared. It's okay if you add 1 squared, you have to subtract also. So see, in order to complete the squares, we required a 1 which we added. But then we cannot just add an expression just out of nowhere. You cannot add it. Since you have added it, we have subtracted it also, so that the value doesn't change but it comes to our expression. Now this is a huge thing for us because this much part is now of the type 3x plus 1 the whole square. It is that way, and this part is changing. It's 5 minus 1, which is 4, and that is 2 squared. So see, you have got the whole thing changed in the form 3x plus 1 the whole squared plus 2 squared. Let's go back to I. I is now becoming integral of dx over 3x plus 1 the whole squared plus 2 squared, which means that this is of the form integral dx over x squared plus a squared, which is 1 over a tan inverse of x over a plus c. So let's apply this. 1 over a for us is 2. So 1 over a tan inverse x is this. You can't call it as x, you have to call it as 3x plus 1. As I said, again you can replace u as 3x plus 1 and work, but we should learn to work like this. So your x is 3x plus 1, x over a is 2. Again, not to forget that it's not x, it is 3x. So you have to take care of the integral coefficient, which is 3. Division by a fraction is multiplication by a reciprocal. So like that, this will become 1 over 6. 1 over 2 divided by 3, 1 over 2 multiplied by 1 over 3, so 1 over 6. 1 over 6 tan inverse 3x plus 1 over 2 plus c. Very simple once you understand it. The completing squared part you have to understand. First trace out the b, and from the b add and subtract b squared. So it's only probably 2 steps for completing square. One is get the b, then add and subtract b squared. That's it. So that's how you complete the squares. Let's quickly move to the 12th question, which is also very much of this kind. Let me check what the question says. 1 over, that doesn't look so simple. Let's say 7 minus 6x minus x squared dx. Once again, let me check. 7 minus 6x minus x squared. Okay, quickly let's consider this. Consider 7 minus 6x minus x squared. As always, now we'll keep the constant away. And these both are negative terms. X squared with negative we don't encourage much because that will only create trouble in substitution. So let's take the minus overall out so that you are left with x squared plus 6x. Now the same logic as we worked here can work over here. See, 6x means you can call it as 2 times 1 times 2 times 1x times 3. Why? Because here the coefficient is 1. So writing this is as good as writing 1x the whole squared. So writing 6x is like writing 2 times 1x times 3, which means that b is 3. If b is 3, so of course this particular middle term you manipulate and you write it the way you want. Okay, you will not change the mathematical value, but depending on your a and b, you maneuver it and you write it so that you are able to complete squares. So in the last case we wrote it as 2 times 3x, but this time we are writing it as 2 times 1x. Why? Because here it was 3x and here it is 1x. So as per your requirement, we maneuver it. So as a result, here b had come as 1, but here b is going to be 3. Then only it suits our requirement. If b is 3, once you have traced out b, we know our next step is to add and subtract b squared. So let's add and subtract b squared. If b is 3, we are going to add and subtract 3 squared. So what we are going to do next is we will add and subtract 3 squared. Now see, let's be a little careful. Actually, inside the bracket, when you add and subtract, technically you're doing just the opposite because there's a minus sign. So when you actually keep the plus, you're actually doing a subtraction. And this we will pull it out because that will create trouble in the completing squares. So let's pull it out. Minus into minus, it will make it plus. So this will become 7 plus 9 minus x squared plus 6x plus 9. Please note this. What we did is we added and subtracted 3 squared, but this minus 3 squared is going to give us trouble in completing squares. So we have just opened the bracket, minus into minus plus, and that we have clubbed it over here with this 7. So what happens? This becomes 16, and this is x squared plus 6x plus 9, which is also 4 squared minus x plus 3 the whole squared. That we got to know right from beginning, that b was 3. If you know a and b, a is 1, b is 3. So obviously it is going to be x plus b is your form always. So it's going to be x plus 3 the whole square. That's enough. You've got the form. Now let's go back to I. I is integral of dx over 4 squared minus x plus 3 squared, which means it's of the form integral dx over root of a squared minus x squared, which is simple sine inverse of x over a plus c. So let's make that substitution. It is sine inverse. X here is x plus 3. A here is 4. And there's no integral coefficient because x is occurring alone. Plus c. That's it. So sine inverse x plus 3. I'll always keep checking, by any chance if there is. One minute, a small clarification. Let me just clarify and I'll get back to you. Just clarification in the answer. Quick clarification, just coming back. Yeah. Oh. Sometimes I like to check the answer from behind and check if everything is okay so that I don't create panic amongst the children when they go through it. That's it. So that's about this. You're getting sine inverse of x plus 3 over 4 plus c. So I think that should be all for this video. With more problems, let's come in the next video. And we are doing great. We are going great with completing squares. Please understand that every time we will trace out the b, okay, and then from the b we will go in for add and subtract b squared. 2 steps. Get the b, add and subtract b squared. You are done with completing squares. That's it. Thank you.